For most of human history, progress moved slowly enough that a single invention could define an entire generation. The steam engine reshaped Europe over decades. Electricity spread across cities over lifetimes, and the early computer took years to leave laboratories and enter homes. Today, that rhythm has completely collapsed. New inventions in science and technology no longer arrive one by one. They emerge simultaneously, quietly at first, then suddenly everywhere, reshaping daily life before society has time to fully understand what has happened. Across Europe, from research labs in Germany and Switzerland to startups in Estonia and university campuses in the United Kingdom, a new wave of inventions is redefining what it means to live in a technological civilization. What makes this moment different is not just speed, but convergence. Scientific breakthroughs are no longer isolated within physics, biology, or engineering. They overlap. Artificial intelligence accelerates medical research. Material science transforms renewable energy. Quantum physics reshapes cybersecurity. Each invention feeds another, creating a feedback loop of innovation that is both exciting and unsettling. To understand where science and technology are heading, it is no longer enough to look at a single device or discovery. You have to see the system forming beneath them. In laboratories across Europe, artificial intelligence has moved far beyond simple automation. Early AI systems were tools that followed instructions. Modern systems learn, adapt, and increasingly collaborate with human researchers. In pharmaceutical research, AI-driven platforms now analyze millions of molecular combinations. In days, a process that once took years. European biotech companies are using these systems to design new antibiotics capable of fighting drug-resistant bacteria, one of the most serious health threats facing the continent. The AI does not replace the scientist. Instead, it proposes solutions that human researchers might never think to explore, accelerating discovery at an unprecedented scale. At the same time, AI is entering physical space. Robotics laboratories in countries like Italy, France, and Sweden are developing machines that can sense, learn, and safely interact with humans. These are not the rigid industrial robots of the past, locked behind safety cages. New generations of collaborative robots, or cobots, work alongside humans in factories, hospitals, and even care homes. They adjust their movements in real time, respond to human gestures, and learn from experience. In Europe's aging societies, these machines are being tested as assistants for elderly care, helping with mobility, monitoring health, and reducing loneliness without replacing human contact. Energy technology is undergoing a similar transformation. Europe's push toward climate neutrality has driven massive investment into renewable energy inventions. Solar panels are becoming thinner, more flexible, and dramatically more efficient thanks to breakthroughs in perovskite materials. Unlike traditional silicon panels, perovskite-based cells can be printed like ink, layered onto buildings, windows, and even vehicles. Researchers are solving long-standing durability problems, bringing this technology closer to mass deployment. The implication is profound. Energy generation could become a built-in feature of architecture rather than a separate infrastructure. Wind energy is also evolving beyond familiar landscapes of towering turbines. Engineers are developing airborne wind energy systems that use kites or drones to harvest strong, consistent winds at high altitudes. These systems require less material, have smaller environmental footprints, and can be deployed in locations unsuitable for traditional turbines. Several European prototypes are already producing power, hinting at a future where energy infrastructure is lighter, more adaptable, and less intrusive. Perhaps one of the most transformative inventions of this era lies in energy storage. Renewable energy is only as reliable as the systems that store it. European researchers are advancing solid-state batteries that replace liquid electrolytes with solid materials, increasing energy density while reducing fire risk. These batteries promise electric vehicles with longer ranges, faster charging times, and improved safety. At the same time, grid-scale storage solutions, including advanced flow batteries and gravity-based systems, are being developed to stabilize national power grids powered largely by renewable in the realm of medicine. Technology is moving inward, becoming smaller and more personal. Wearable devices have evolved from simple fitness trackers into sophisticated health monitors capable of detecting irregular heart rhythms, measuring blood oxygen levels, and even predicting illness before symptoms appear. European health systems are exploring how these devices can integrate with public healthcare, shifting the focus from reactive treatment to preventative care. This represents a fundamental change in how medicine is practiced, where data continuously informs intervention rather than waiting for patients to become ill. Beyond wearables, scientists are developing implantable technologies that blur the line between biology and machinery. Neural interface research, conducted in universities across Europe, aims to create devices that can read and stimulate brain activity with extraordinary precision. These interfaces hold promise for treating neurological conditions such as Parkinson's disease, epilepsy, and spinal cord injuries. The long-term implications extend even further, raising questions about human enhancement, cognition, and the ethical boundaries of technological integration with the body. Materials science, often overlooked by the public, is quietly enabling many of these breakthroughs. New materials designed at the atomic level are giving rise to stronger, lighter, and more sustainable products. Graphene, first isolated in Europe, continues to inspire applications ranging from ultra-fast electronics to water purification systems. More recently, researchers have developed self-healing materials that repair microscopic damage automatically, extending the lifespan of infrastructure, vehicles, and electronic devices. These inventions reduce waste and maintenance costs, aligning technological progress with environmental responsibility. Construction technology is also being reinvented. 3D printing, once limited to small plastic objects, is now being used to print entire buildings using advanced concrete formulations and robotic systems. European projects have demonstrated the ability to construct houses in days rather than months, using less material and producing less waste. When combined with sustainable design principles, these methods could help address housing shortages while reducing the environmental impact of construction. Transportation is another domain where science fiction is becoming reality. Electric vehicles are only the first step. European researchers are developing hydrogen fuel cell systems for heavy transport, including trucks, trains, and ships. Hydrogen, when produced using renewable energy, offers a zero-emission alternative for applications where batteries are impractical. Meanwhile, advances in autonomous driving technologies are reshaping how vehicles perceive and navigate the world. Rather than replacing drivers entirely, European approaches often emphasize driver assistance and safety, reflecting cultural priorities around responsibility and regulation. In aviation, innovation is focused on efficiency and sustainability. Electric and hybrid electric aircraft prototypes are already flying short routes, and European aerospace companies are exploring hydrogen-powered flight. These technologies aim to reduce emissions without sacrificing connectivity, a crucial consideration. For a continent defined by international travel and trade, communication technologies are evolving just as rapidly. The rollout of advanced 5G networks across Europe is enabling ultra-low latency communication, critical for applications such as remote surgery, autonomous vehicles, and smart infrastructure. Beyond 5G, researchers are already working on 6G concepts. envisioning networks that integrate terrestrial and satellite communication, providing seamless connectivity even in remote regions. This infrastructure will support a new generation of digital services that are deeply embedded in physical environments. Quantum technology represents perhaps the most radical shift in computing and communication. European investment in quantum research has accelerated dramatically, recognizing its strategic importance. Quantum computers, though still in early stages, promise to solve certain problems far beyond the capabilities of classical machines. In parallel, quantum communication systems are being developed to create theoretically unbreakable encryption, transforming cybersecurity. Europe's emphasis on data privacy and digital sovereignty makes this area particularly significant. As these inventions emerge, they are forcing society to confront new ethical and regulatory challenges. Artificial intelligence raises questions about transparency, bias, and accountability. Biotechnology challenges traditional definitions of health and identity. Energy technologies reshape geopolitical relationships built around fossil fuels. Europe's response has often emphasized regulation alongside innovation, seeking to balance technological progress with social values. This approach may slow certain developments, but it also aims to ensure that technology serves the public good rather than undermining it. Education itself is being transformed by these inventions. Digital platforms powered by AI are personalizing learning, adapting content to individual students' needs and learning styles. Virtual and augmented reality technologies are creating immersive educational experiences, allowing students to explore historical sites, conduct virtual experiments, and collaborate across borders. In a continent defined by linguistic and cultural diversity, these tools have the potential to create more inclusive and accessible education systems. Agriculture, one of Europe's oldest industries, is also becoming a site of high-tech innovation. Precision farming technologies use sensors, drones, and AI to monitor soil health, crop growth, and weather patterns in real time. This allows farmers to optimize water usage, reduce chemical inputs, and increase yields sustainably. Vertical farming systems developed in urban environments are using controlled lighting and climate systems to grow food year-round with minimal land and water use. Addressing food security in a changing climate. Environmental monitoring technologies are giving scientists unprecedented insight into the health of ecosystems. Satellites, sensor networks, and AI analysis are tracking deforestation, pollution, and biodiversity loss with high precision. This data is informing policy decisions and conservation efforts across Europe, enabling faster and more targeted responses to environmental threats. As these inventions continue to evolve, one pattern becomes clear: technology is becoming less visible even as it becomes more powerful. The most impactful inventions are not always the ones that look dramatic, but those that quietly integrate into daily life, reshaping systems from within. Smart grids balance energy automatically. Algorithms optimize logistics without human intervention. Medical devices detect disease before symptoms appear. The future of science and technology is not about spectacle, but about subtle, continuous transformation. This raises a deeper question about what progress actually means. In the past, technological advancement was often measured by scale and power. Today, it is increasingly measured by efficiency, sustainability, and human impact. Europe's scientific and technological landscape reflects this shift, emphasizing solutions that align with social responsibility and environmental stewardship. The next decade will likely bring inventions that feel almost invisible compared to the dramatic breakthroughs of the past, yet their cumulative impact may be far greater. As science and technology continue to merge, the boundary between the natural and the artificial will blur further. challenging long-held assumptions about what it means to be human in a technological world. If history offers any lesson, it is that societies that engage critically with new inventions rather than blindly embracing or rejecting them are best positioned to shape their outcomes. Europe's approach, combining innovation with reflection, may offer a model for navigating this complex future. The inventions emerging today are not just tools. They are choices shaping the kind of world that future generations will inherit. One of the most profound shifts comes from the intersection of biology and technology. Synthetic biology, a field once confined to niche laboratories, is now producing inventions that could redefine life itself. European research centers are creating engineered microbes capable of producing pharmaceuticals, biofuels, and even biodegradable materials. These organisms are designed with precision, using tools like CRISPR gene editing to rewrite DNA with unprecedented accuracy. The implications are staggering. Diseases could be treated at their genetic roots, industrial processes could become carbon neutral, and pollution could be tackled at a microbial level. Yet with such power comes immense responsibility, prompting rigorous ethical debates across European policy circles and scientific communities. Nanotechnology, often described as the manipulation of matter at the scale of atoms and molecules, is another field delivering radical inventions. In medicine, nanoparticles are being designed to target cancer cells directly, delivering drugs with pinpoint accuracy while leaving healthy tissue untouched. In environmental applications, nanoscale filters can purify water, capturing contaminants that traditional methods cannot. Across Europe, startups and university labs are translating these discoveries into practical solutions, demonstrating that even at scales invisible to the naked eye, technology can have a monumental impact. The world of computing is evolving alongside these biological and material innovations. Neuromorphic computing, which mimics the structure and functioning of the human brain, is emerging as a potential alternative to traditional silicon-based processors. European labs are exploring how these systems could handle tasks like pattern recognition, sensory processing, and decision-making far more efficiently than conventional computers. By drawing inspiration from biology, these inventions are not only more energy efficient, but also capable of learning and adapting in ways that traditional computers cannot. In parallel, Europe is witnessing a surge in human-machine collaboration. Exoskeletons, once confined to industrial or medical rehabilitation contexts, are becoming lighter, smarter, and more responsive. These wearable devices amplify human strength and endurance, enabling workers to lift heavier loads with less strain, soldiers to carry equipment more efficiently, and patients with mobility impairments to regain independence. Advanced sensors, AI-assisted motion control, and ergonomic design converge in these inventions, reflecting the European emphasis on blending functionality with human-centric design. Space technology, too, is undergoing a renaissance. European nations, both through the European Space Agency and private ventures, are developing inventions that expand humanity's reach beyond Earth. Reusable launch systems, miniaturized satellites, and autonomous space robots are making space more accessible and cost-effective. Observational satellites equipped with AI-driven analytics are monitoring climate change, natural disasters, and maritime traffic, providing data that informs everything from environmental policy to disaster response. The convergence of AI robotics and aerospace engineering demonstrates how inventions across fields amplify one another, creating possibilities that would be unimaginable in isolation. Transportation on Earth is also transforming through a combination of inventions. Hyperloop concepts, magnetic levitation trains, and autonomous electric ferries are being tested across Europe, each promising to reshape mobility. These systems are designed to reduce travel times, lower emissions, and integrate seamlessly with urban planning. Smart traffic management, powered by AI and real-time data, is improving efficiency in cities, while adaptive public transit systems respond dynamically to demand. The cumulative effect is a continent moving toward a transportation ecosystem that is cleaner, faster, and more responsive than ever before. Energy harvesting technologies continue to innovate in unexpected ways. Europe is experimenting with bio-inspired systems that mimic the way trees and animals capture energy. Artificial leaves that convert sunlight into chemical energy, piezoelectric materials that generate electricity from motion, and microbial fuel cells that produce power from organic waste are no longer theoretical. These inventions promise decentralized energy systems that are resilient, sustainable, and integrated into everyday life, fundamentally altering how power is produced and consumed. The digital revolution is also redefining creativity and human expression. Generative AI tools capable of producing music, visual art, literature, and even complex design schematics are democratizing creative production. European artists and designers are experimenting with these systems not as replacements, but as collaborators exploring new aesthetic possibilities. The philosophical implications are significant. If machines can create, how do we define originality, skill, and artistic value? These questions are being debated in cultural institutions and academic circles across the continent, shaping policies around intellectual property and the future of creative labor, augmented reality, and virtual reality. Technologies are similarly redefining human experience. Museums, historical sites, and cultural institutions in Europe are adopting AR and VR to provide immersive experiences, allowing visitors to witness history, explore inaccessible environments, and engage with content in interactive ways. Beyond entertainment and education, these inventions are influencing therapy, social interaction, and professional training. Surgeons can rehearse complex procedures in virtual environments. Students can explore laboratory experiments safely and urban. Planners can visualize infrastructure before construction begins. Security and privacy are evolving alongside these innovations. Biometric authentication, decentralized identity systems, and blockchain-based verification are being developed to protect data in an increasingly connected world. European regulation, exemplified by the General Data Protection Regulation, GDPR, emphasizes user control and consent, ensuring that technological advancement does not come at the cost of fundamental rights. Innovations in cybersecurity, including AI-driven threat detection and quantum-resistant encryption, aim to secure critical infrastructure, personal data, and national security interests against rapidly evolving threats. The rise of the Internet of Things (IoT) exemplifies how small, interconnected devices collectively transform society. Sensors embedded in homes, vehicles, and industrial